way we put it together, or she put it together. So y equals x squared times e to the x. Now, that times is not real clear, but it's there. This is the product rule. Do you remember the derivative of the product of f times g is f times g prime plus g times f prime. You can't take, I know, I wish you could, but you can't take the derivative of the x squared times the derivative of e to the x because you don't get the right answer. So, and we did not prove to you why that is what it is. So it's x squared times the derivative of e to the x, which is e to the x. You'll need to know your derivatives of your trig functions and such, plus, and then it's e to the x times the derivative of x squared, which is 2x. If you look at the answers, it doesn't match anything, not the way it's written at least. But can I factor anything out of here? Yeah, I've got an x in each one, and I've got an e to the x in each one. So let's factor at least one of the x's out. So y prime is equal to e to the x. That gets rid of that one and that one. It gets rid of one of the x's. And so I'm left with what? X here plus what's still left? 2. And that is C.
No, since it says it's going to be multiple choice.
It's going to be multiple choice questions without the multiple choice answers. So you're going to have to show your work. So would this answer be okay? Yes, it would. It'll be a question like this without the multiple choice answers. So would this solution here be okay? Yes, it would.
But so the test tomorrow is going to be on stuff like this. It's not going to be on the chain rule.
Oh, it's going to be on the chain rule.
This. Other stuff.
These are actual AP questions. You need to do this and the homework. Now, this is all the ones you can do. Almost all. I think I skipped one, except for the last 3 are online. And there's a video. There's a little bit of downtime because sometimes I forget to turn the video off. I just did. They're in Schoology. There they are. So you go under AB Calc Resource, AB Materials, go to the pilot chapter. It's the only chapter 3 there is anyway, because I hid the other one. And then these are all the videos, and they go all the way through. Now, I don't have today's video up because it takes a while to upload it to YouTube, and I haven't had a chance to do it because this is my prep hour. Okay. I don't like 91, so we're going to skip that one. Okay, 91's okay, but I can tell you it's not going to be that hard on the test. So let's go to 83. And then we'll come back. I'll just get the 3 that I need to get. I always do that. Hate that. So I'm going to go to 83 because it's a nice little calculus problem. And then we can go to the beginning or whatever ones you have questions on. I don't care. Now, this is a limit. Now, everything is fair game. Because a derivative is a limit. So, you still have to know limits. So the first thing you always do is substitute it in. And if you put in a, you get a squared minus a squared over a to the 4th minus a to the 4th, which is 0 over 0. You put in a, you always, when you do a limit, substitute the value in. I'm an AP reader. I've done it for 3 years. And they expect to see the 0 over 0 if this is a free response question. And if you don't do that, you will not get full points. I'm not saying I agree with that, but I'm saying that's the way it was graded when we did that problem. So what are you going to do? If you get 0 over 0 and these are polynomials, then I know I have a hole there. And I know that the factors, some of the factors here have to be the same as that. Well, I could factor x squared minus a squared further, but I don't really need to. Whoops, that's x squared. Sorry. I'm going to leave that one. Can you factor the denominator, though? Because I know that if I get 0 over 0, that this has to divide into that. Well, how about x squared minus a squared? What's left? X squared plus a squared. Because the limit is what the function's getting close to when you get close to a. It's not equal to, it doesn't ever get there. So what is it getting close to? I don't care what happens at a. So as long as I'm not at a, I can divide numerator and denominator by x squared minus a squared. And then I get 1 over x squared plus a squared. And it's the limit as x approaches a. What's that give me? Now what do? Substitute it in, right? So it's equal to 1 over a squared plus a squared. And if you look at your choices, be careful. Here's where they get your algebra. Do they have an a to the, oh, they didn't even do that to you. They could have given you an a to the fourth, but what's the answer? 1 over 2a squared. So that's B. Kind of weird, but now 77 is a graphing calculator problem, but we can, and in terms of solving it, but let's do 77. You might run into the graphing calculator problems. I don't remember looking at the second half of the test, just the first. So f of x is equal to 3e to the 2x, and g of x is equal to 6x cubed. You know, I kind of know what they look like. At what value of x do the graphs of f and g have parallel tangent lines? So 3e to the 2x looks something like that. And 6x cubed will look something like this. Okay? So I want parallel tangents. So maybe I'm going to estimate something like that. I don't know exactly where it is. So what do you have to find? The slopes, right? How do you find slope? It's the only thing you know what to do in calculus. How do you find slope? It's the derivative. So what's f prime of x? Now this is where we get to practice. What's f prime of x? It's 3. Ignore the constant. Do you know why? Do you know why you can just pull that out? Maybe not. So 3 times the derivative of e to the 2x, which is e to the 2x, times the derivative of 2x, that's the chain rule, times 2. Then you would leave the e to the 2x alone and take it times the derivative of 3. But what's the derivative of 3? 0. That's why you can pull that constant out. Because when you apply the product rule, which you really always should, this term is always 0. So you can just ignore the 3. A constant. You can't ignore variables. So this is equal to 6e to the 2x. And g prime is easier. That's equal to what? What's the derivative of 6x cubed? 18x squared. And you want to know where they're parallel? Yeah, parallel. So what's got to be true about these two guys? Their slopes have to be what? The same. This graphing calculator, I can't solve it algebraically. It's not possible. I don't even think I want to do it with a series. So I would put it in my calculator, and you could put this in for y1, this in for y2, and find where they intersect. Here's the problem with that. You have to know how tall the window is. What if I subtract these? What if I write 6e to the 2x minus 18x squared? What would I get? 0. And then all I have to do is figure out the x's. I don't care what happens. I'm looking for zeros. So all I'm looking for is where it does this. Where does it cross that axis? So I don't care about how tall the window is. I just have to go from what? To have a 0, this had to be positive, and then this had to be negative or negative positive. Because the number's positive and it becomes negative, it had to go through 0. Does anybody remember the name of the theorem? Starts with an I. Intermediate value theorem. We live in Minnesota. We do it all the time. We may be talking about freezing, or we may be talking about 0. Temperature's above 0, the temperature's below 0. Well, if it started out at 10 below and it went to 10 above, it had to be 0. That's it. It had to be 0. You will see the intermediate value theorem on the exam, so we'll have to hit on it. We'll hit on it more in the spring. You've done it already. The answer is C if you use it. Pardon? Yes. Yes. I don't think we see it tomorrow.
remember how to find a derivative of 3e to the 2x?
The derivative with respect to x of 3e to the 2x, you ignore the 3, and you just do the derivative of this, which is e to the 2x. E to the x is always e to the x, then times the derivative of that function. So it's times what? 2. They just asked me, make sure I understood how to do that one. We'll get some more.
Why are we doing this as more implicit definition?
Oh, well, it gets implicit. You need to know all of this.
For the test as well.
All of it. This is the chain rule. So we start with the chain rule. We can't throw out the derivative of the sign, the derivative of e to the x, can't throw any of those things out. E to the x and e to the 2x was in the chain rule section.
Why did you plus e to the 2x times 0?
Because then, if you want to use the product rule, because that is times, then I would do plus e to the 2x, then times the derivative of the 3, which is, what's the slope of a constant horizontal line? 0. There was a homework problem that asked you, it was a while ago, the derivative with respect to x of some constant times f of x. And they asked you to show it was equal to this. And we may skip to a problem that relates to this, because I know exactly where it is. Well, why is it that way? Because first it's k times the derivative of f of x with respect to x plus, then you leave this one alone, f of x times the derivative of k with respect to x. But what is that derivative? That's 0. That's why you're allowed to pull that constant right on out of there. I really have to use the products rule. So let's do the problem that's like that. 76 is not really relevant. And I don't think we got to 28 in my other class, but let's do that one. And I'm going to keep going backwards. I know where it is. Just have to find it. Oh, yeah, we got to get all the way back to 18. I think it's the one right before that. Nope. No, I'll find it. I still got to go back further. It's page 12. It says page 12 on the bottom. It has this picture. It's problem number 8. It's related to that. So it's page 12. It's out of order, number 8. And it says f and g are differentiable. What does it mean to be differentiable? Differentiable means you can find the derivative. That's all. F prime and g prime exist. Okay, and then we have some conditions. It says g of x is greater than 0. Now, in math, we're very lazy. I don't want to write for all. So we have a symbol meaning for all. It's right here. It's an upside down A. That means for all x. So in other words, g is positive everywhere. And you're saying, well, I don't know why I care about that, but you'll see why. And then I know that the f of 0 is equal to 1. And then they give me h is equal to f times g. I don't like all those x's in there. And then they tell me, one more statement they tell me, h prime is equal to f times g prime. Okay. First off, it's hard because look at all the words. A lot of reading. And you have to understand everything. So first thing is I have two functions. I can find the derivative of each one. These are some conditions I'm going to use in a moment. But they say h is equal to f times g. Now, forgetting that over there, what's h prime? It's the products rule. It's what? It's f times g prime plus g times f prime. But they told me that for the function that we're talking about here, that h prime is equal to just f times g prime. That tells you something. It's very subtle. It says, what's this value? That's 0. Now, either g is 0, because of zero product property, remember that? Or f prime is 0. Well, g can't be 0. Why? Because it said it was positive. If I didn't have that condition, I'd be stuck, because one or the other has to be true. So that can't happen. That's right. This is where the thinking comes in with the concepts. You have everything you have, tools. You have all the tools. You have to think and put them together. If the derivative of my function is 0, then f has to be equal to a constant. There's one more leap to make. I've seen those movies with those leaps. This is one leap. Well, if f is a constant and they tell you that f of 0 is 1, what's the constant? 1. So f of x is equal to 1. So what's the answer? Oh, yeah, they do that. They put a lot of twists in here. That's why we do these problems. Our weakest link is the multiple choice, to be honest. Because we don't have that many to work with. So the answer is E. Now, do you see why I did that? Why I connected it with the other problem? They may be off 2 different exams. Same concept. The fact that the derivative of a constant function is 0. It's kind of interesting. Okay, I do want to make sure I get all the problems covered, so I'm going to go back to the back of the packet again, and then we can jump to wherever you'd like, because the only thing that really matters is, for me right now, is getting the last ones. Let's see. Yes. That's, I don't know. I didn't even get that one, but now I had my, now you can do 76. Wouldn't hurt to do 76. Let's do it. I didn't get there in any of my classes. It's not that it's that big a deal. The 76 is a beautiful graph here. But I found out in my classes that not everybody still understands the limit. My question for you, without even doing anything else here, is that function continuous? No. Some of my students kept saying, yeah, the function's continuous. No, it's not. There's a break in the graph. It says, now, which of the following statements about the function is false? Please make sure you read through everything. A says f is continuous. I hate these negative ones. Is that true or false? Here's how I do it. I read the statement and say, f is continuous. Is f continuous? No, it's false. Now, what's the question? Which one must be false? There's only one answer. It's A. But let's look at B just to make sure we understand things. It says f has a relative maximum at x equals a. Now, we haven't done that, but that's why this one kind of doesn't apply. But within this neighborhood here, is there a maximum value? Yeah, those are the people with the best Christmas lights on the street. There's always somebody, isn't there? That outdoes us all. There used to be some really nice ones in Chan, but because it caused a traffic jam, they don't do that anymore. So they were told not to. X equals A is in the domain. So what this is saying is that my function is defined at A. Yes, it is. So this is true. That's true. And then D, it says the limit as x approaches A from the right of f of x equals the limit as x approaches A from the left of f of x. Sure. I just look at it this way. You're traveling down the road. You're coming from one direction. Your friends are coming from the other direction. Are you gonna meet? Yeah. But it's the limiting value. It's a limiting value. What is the limit? What's the y value? Getting close to. You're right. The y value doesn't exist there, but it's getting close to the same value. Yeah, that's the hole in the road on 41 when they tore that up. So that's true. And the last one, does the limit exist? Because that's true, E, the limit must exist. That's what we mean by a limit existing. Okay, so you might have forgotten some of that. But you know what? We are still getting ready for the AP exam. Now, it could have been, you have to go through them all. But I knew it was discontinuous, so I'm done. But be careful, because sometimes they give you some distractors as the first answer. Okay, next one, which is very relevant. I'm going backwards. Number 28. Maybe somebody wants to come up and try it. This is just what I call a skill problem. You have to go backwards in order. I'm not a sequential person, but this time I have to be. It's on page 23. We're starting from the back. I have got to do that one, and there's another one. But okay, so you want me to do it, or somebody want to come up and do it? Okay, we do the outside function. What's the derivative of tangent? Secant squared. You have to memorize those. Secant squared of 2x. Now, I found that my students thought that was the tangent times 2x. No, it's not. That's the angle. It's the tangent of 2x. So then we have to multiply that by the derivative of the 2x, which is 2. Yes. I don't know who that is. Oh. Okay. Should I have put it, you guys, should I put in pi over 6 to begin with, or should I do it now? If I put it in to begin with, what's the derivative of the tangent of whatever that is? It's 0, isn't it? You always do your derivatives and then substitute in. Okay, so now I want f prime of pi over 6. So that's equal to secant squared of 2 times pi over 6. And there's a 2. Let me put the 2 in front so I don't get it confused with the angle, because it's not times the angle. So how am I going to find that? It's 2, it's the secant of pi over what? 3, and I'm going to square that. Now you got to remember what secant is. And I need to know what pi over 3 is. Do you know how many degrees pi over 3 is? 30. I want it to be 30 because of the 3's, but I know I'm wrong. That's how I remember it. So it's going to be 60. Do you know how to convert if you don't know? You multiply by 180 degrees over pi. Now, do you know your triangles? Did Mr. Dahman show you triangles? I'm sure he did. Yeah. You have to know everything. Everything for the whole year. Okay. Here's how I do it. I start with an equilateral triangle because all the angles are 60 degrees. And I know a lot about geometry because I taught geometry for 8 years and I haven't forgotten it for some reason. If I drop the altitude to the base, this bisects the base and it's perpendicular and it bisects the angle. So there's my 30, 60, 90 triangle. Now, I don't know about you, but I don't really want fractions. So instead of making the side 1, I'll make the side 2 because this is 2. So what's this leg? 1. And anytime you have a leg that's half the hypotenuse, it's always 30, 60, 90. You need this in the ACT and SAT. What's this side going to be? Pythagorean's theorem. 2 squared minus 1 squared is square root of 3. So you have to know that triangle. My recommendation is always, when you first get your exam, draw your triangle so you can reference it at any time. Because you're going to be stressed. And you're going to be saying, oh my goodness, I can't remember what the sign or whatever is. Well, if you have your triangle there, you just go look at it. You're still going to be stressed. I'm trying to reduce your stress. Okay, now, next hard part. What's the secant? The secant of x is 1 over the cosine of x. And by the way, that's the cosine of x to the negative 1 power. Is that this? No. And you got to fault mathematicians for this one. Because it looks like it should be the same, but it isn't the same. An inverse trig function is an angle. That's a theta. This is not. This is the ratio of the sides. So they're not the same. So if I cross it out. So now, the secant's 1 over the cosine. So the cosine would be 1 over 2. So the secant is the reciprocal. So what's the secant? 2 over 1. So there it is. It's 2 times 2 over 1 squared. So what's the answer? 8. But they gave you the radicals as choices, didn't they? Because they knew that some of you would get the radicals in there. Don't be too radical. Yes.
I missed the part where like 2 secant square
Okay.
pi over 6 goes to being
Well, it's 2 pi over 6. It's pi over 3.
But like, why is it raised to, oh.
Because this, you can't do secant squared like this. You can't put it on your calculator that way either. If you want to graph sine squared of x, you have to do sine of x quantity squared. You got to do it that way. Okay, we got one more, and then we can go back to the beginning if you prefer the beginning. It doesn't matter because they're all the same. Now, they do like to, actually we have 2 more. They do like to, on the exam, put some of the easier ones towards the beginning to calm you down a little bit. Sometimes. I mean, but sometimes the second one is kind of hard. Okay, we're not going to look at the choices here in 23. We are just going to look at the graph. And I have to draw a nice graph to do this. We're just going backwards. Anything that says, oh, that one's kind of weird. I skipped ones that you don't have to know. That's the intermediate value theorem. You don't have to know that one. If you do, blame me. I'll give you the answer if you want to work it out. Oh, he gave you the answers? Oh, I'm going to put them up too. Okay, that's a little crooked, but that's okay. We can live with it, I hope. Okay, it asks you to graph the derivative. Now, I'm not going to look at the pictures because that's deceiving. What's true about my derivative here? It's 0. That's at A. What's my derivative here? It's 0. My derivative here is at 0. Now, what's true about the slopes here? They're all positive. So my graph has to be above the x-axis. Then, these are all negative slopes, so my graph must go below the x-axis. Now look at your choices. Which is it? It's A. I didn't look at the answers. I drew the graph because sometimes when you look at the answers, you just get confused and you get stressed. Just do the problem and then say, oh, there's the answer, it's A. If you don't see the answer there, then it's time to get stressed. That's it. That's all there is. Okay, one more, 18. And then I've got everything before that, but we can keep going backwards if you want because there's another nice one with the chain rule. 18. But I might turn the recorder off. It says an equation of the line tangent to this graph. You don't know what it looks like. I kind of do. At 0, 1. And actually, it doesn't really matter what it looks like. It's going to be the cosine curve, but it's going to keep increasing, so it's going to look something like this. But I don't really care. So here is 0, 1, and I want the equation of the tangent line right here. Might not be right there. Whatever. I'll just draw a tangent line. I'm not sure where it is. Okay. So I start with what I don't know, and I need to know the equation of a line. So we start there. What's the equation of a line? No y equals mx plus b. Y minus y1. You know where that comes from, right? You know where that comes from. This is just slope formula. That's all it is. You start off with y minus y1 over x minus x1. That's equal to m. If you cross multiply, you get that. Which is why it's nice, to tell you the truth. And do I have, well, let's see what I need. I need an x value. I have it. I need a y value. I have that too. They didn't have to give me that. And then I need the slope. That I don't have. That's what we're going to have to do some work with. Okay, so what's my x value? Let's put in what I know, because I like to feel confident here. What's the y value? 1 equals my slope, and slope's always, always, always a number. What's the x value? 0. How do you find the slope? It's the only thing we've been doing. Derivative. So y equals x plus the cosine of x. I want y prime. Well, you should be done before I write it down. 1. And the derivative of all the cofunctions are negative. All of them. The derivative, he did he do cotangent? Cotangent, it's negative. So it's negative sine of x. And then I have to find out what this value is when x equals what? 0. If you break it down, it is. Math tells you what to do if you know your rules.
Is it one times negative sine of x?
No, it's 1 minus. Okay, here's the question. And being an AP reader, I see this all the time. That's a plus sign. It's 1 minus the sine of x. I see a lot of students write that when they mean this. That's not what I mean, though. But that is not the same as that, is it? So a lot of students mean this. They want this one, but they write it this way. Well, we've been very kind about the parentheses. I call it the case of the missing parentheses. Depends on the problem, but usually we overlook it. Drives me nuts, we overlook that. Because there are other things we don't overlook, like any math that's written incorrectly. Any math that's written incorrectly. For instance, 2x plus 3 equals 7, and you subtract 3, so you get 4, and then you divide by 2 equals 2. I know you solved it correctly. That's not the point. The point is, that's way wrong, and you can't do that. So you cannot write math that's not correct, or we will take points back.
Why did you say the product rule?
Because this isn't the product, this is plus. Yeah. Okay. Now, how are you going to find the sine of 0? You're just going to grab the sine function. You're not going to use the circle, because that's too hard. This is much easier. What's the sine of 0? 0. Doesn't Mr. Dominic does this, right? He does it this way, doesn't he? Or is he just assuming you guys know it? Oh. Well, I can't do that. I assume you don't know it. What's the cosine of 0? Because, well, first off, it can't be the same as the sine, can it? No. And then, so here's 2 pi. Where's this? Pi. So what's the cosine of pi? Negative 1. Just, these are quick little tricks. You do the unit circle and you try to find them on the quadrantal angles. I mean, I can, but it takes me twice as long, maybe 3 times as long. This is a time test. You got to get it done in the time you're given. So that's going to be 0. So what's y prime equal to? 1. So I just put that back in here. That's 1. And I solve for y because they gave me y equals mx plus b. But if we can't do this, we're in serious trouble, right? I'm going to erase this, get out of my way. So I get y minus 1 equals 1 times x minus 0. So y equals x plus 1, and the answer is, oh, I lost my packet. Oh. It's been a long day. This is my 6th class, and I have 4 preps. So if I keep myself straight, I'm lucky. Okay, and the answer is B. So let's go one step back, another page, because there's a really nice little problem there. Just keep going backwards, I don't care. And we've done this in my class, but I'll repeat it. So this is already on the other videos. So I'll just record the whole thing. You can't do 17. Take 17 off. You might be able to figure it out, but we don't have the stuff to do it. No. We don't know that because we don't know about second derivatives and what they mean. All I want is the derivative of this. Is anybody brave? Who's brave? Okay. Start outside. Cosine of what? Whatever. Remember did Mrs. Dowman give you the suckers? The Tootsie Rolls? Pops. When you take the cover off the Tootsie Roll Pop, does the inside change? It is. It's with respect to the inside. Does the inside change? No. Then, when you eat the candy, does the chocolate part change? No. Oh, yeah, let him. Okay. Times Now, what's the derivative of this one? E to the negative x times the derivative now of this one, which is negative 1. That's the answer. Which answer is it? It's E. It's E. You see that? That's why it's so important to check solutions. Okay, I'll put the answers up, but the solutions on the PDF files of all the things I did every problem in class. They're all up there. Now, some might be done by my students, but they're still up there.
When do you know how to do product rule and chain rule like this?
You always do the chain rule. This is not times. This is the sign of. Now, if I had the sign of x times e to the minus x, that's a different problem. Okay, do you see the difference? This is a product. In this case, might as well do it. It would be the first times the derivative of the second. Now, this is the chain rule because it's a composite. Yes. Product is f times g. Composite is f of g. See the difference there? So then this would be e to the minus x times the derivative of that, which is negative 1. And then, because it's a product, you go plus, leave this guy alone, times the derivative of sine, which is cosine. L times the derivative of x, but that's just 1. How about 14? Yeah, that's just the derivative. Another word for the same old, same old. And when you take the AP exam, there are two things you do. You integrate or you differentiate. You do one of the two. I highly recommend that you at least look at the smart boards for the problems I don't get to, because I did this for 2 days. If you watch the videos, it's 2 hours. It's real time. Okay, I want the velocity equal to 0. How do I do that one? Derivative. Because velocity is dx dt. Now, it's not v of 0. It's v equal to 0. So what's the derivative? This is an easy one. And I want that to be 0. Right, now, we don't have to factor. You know what it means to solve? It means to find numbers that make the sentence true. So I can look at that and see t is what? 3. Keep math as simple as I can. Now, when you go online to look at multiple choice questions and answers that are online, I should have on the answers, where it's just the list of the ABCD stuff, they should tell you how many people got it wrong. They do the statistics on that. There will be people who got that wrong. Pat yourself on the back that you got it right. All right? When we compete against everybody in this country. And a lot of those teachers are not as prepared as the 3 of us are. And so the kids don't get the preparation that you guys get. Okay, let's keep going. We might as well keep going till the bell rings. We're going backwards. 12 and 13 are interesting. We've done 12. It's been on your test before. 13, I can just quickly, if you want to see it done, you may do that. But where is a function not differentiable? Where do derivatives not exist? Here it's 0, but in general, what is it? What's wrong with 0? Because it's discontinuous there. You know, if the function doesn't exist at the point, how are you going to take a derivative? And the slope from the left has to equal the slope from the right because it's a limit. So a vertical tangent's a problem. That wasn't what I was thinking of. But where's the other problem? There's another problem. I'll get the vertical tangent. Sharp corners. Remember the absolute value? I just call it sharp corner. You can call it a cost. Anytime, something like this, all counts. Can't do that. Is that mine? I took the sound off. Okay. That's pretty good. I went all day with the sound off. That's the first message I got. Okay. And then where else? Vertical tangents. Well, the squiggles are discontinuity. Why can't you have a vertical tangent? What's the slope there? It's undefined. What? squiggles, that'd be up here. I call them wiggles. Corners. Sorry, you're not used to my writing. Okay, so the answer to 13 is B. And the answer to 12 is E because this is a limit. And so on 12, f of x is equal to this integral. I strongly recommend, this is not enough practice, just this one class today. It's not enough. You need to go back and do the rest of the problems. And like I said, you can check them with the PDFs. Now, the log function is continuous everywhere. So the limit exists everywhere in its domain. So that's not a problem. X squared is not a problem either. The only place I have to worry about is, do those two functions match up? So is the limit from the left of f of x, is that equal to the limit from the right? Well, what is the limit from the left? You use this one. It's the log of what? 2. I know it bothered you when we gave it to you. It was a partner test. Then you put 2 in here. It's 2 squared times the log of 2. Are those equal? I don't care if you don't know what the log of 2 is. It doesn't matter. Are these equal? No. Since the left doesn't equal the right, the limit does not exist. If this were free response, you would have to say, since the limit from the left does not equal, you just say it in words or symbols. Somehow you got to say it. It doesn't exist. Okay, number 10. We're doing pretty well. How do you find the instantaneous rate of change at 2? Now somebody should come up here and do this. I want instantaneous rate of change when x is 2. So what do I want to find? What am I looking for? The derivative at 2. If I put 2 in, I'm in trouble. I'm in big trouble. I copied it twice wrong today. It's x squared minus 2. It makes a big difference too. X squared minus 2. So what rule do I have to follow on this one? Quotient rule. For those of you who have forgotten it, I have a few of those. Okay. It's the high and low. Okay. I do it this way. I start in the denominator, go up, and then come back down. So it's g times f prime minus f times g prime all over g squared. You should have a piece of paper out, pencil. Guys, we don't have time for this. Okay, so can you do it? Oh, okay. You want to come up and do it? You don't even have any paper out. Come on. Come on. This isn't that hard. It's the denominator, which is what? X minus 1 times the derivative of the numerator. What's that? 2x. Don't put the 2 in yet. Minus the numerator. Guys, look at that. X squared minus 2 times the derivative of the denominator, which is 1. All over the denominator squared, which is x minus 1 squared. And then you put in 2. Don't simplify it, because you know what you'll do. Algebra is not our strong suit, right? So let's just put 2 in. And I want to get the answer right, so I'm going to put the substitution in here. Well, 2 times 2, that's 4. Minus 2 squared minus 2, all over 2 minus 1 squared. So that's going to give you what? 1 times 4 is 4. And what's this? 4 minus 2 over 1. Do the arithmetic that fast, you guys. It's just arithmetic. It's easy arithmetic. Okay, and the answer's 2, and that's it on that one. We keep going back. We did 8. That was that weird one. Oh, let's have you do 6. That's important. It's an implicit differentiation. Do not forget to study the derivatives of the inverse. I think there's only one. Now, somebody want to come up and do this one. He's going to do this one. All right. Look at your choices while he's coming up here. Take a look at them.
Microphone, please.
Oh, yes. Yes. You're just going to come back and watch this. Somebody people watch it.
Oh, shoot. I don't know what to do with this. Okay. I don't know. Oh, God. Oh. Go. Sorry, the clip didn't work. All right. So the first thing we're gonna want to do here is take the ddx both sides, right? So we got d dx of x squared plus d dx of xy equals the d dx of 10. So we know this is the power rule, so that's going to be 2x. Easy. Next thing we got here is we got 2 multiplying. We know what that is, right? Quotient rule. Product rule. Just kidding. I'm just screwing with you. Good thing you told me. Well, I know what it is though. So let's say this is f and this is g, and we know it's f prime of g times f plus f g prime. So x. What's the derivative of x? 1. So plus 1 times y plus x. Now this is an implicit function, so it's dy dx. I don't know what you're talking about. I didn't hear anything. So dy dx, and this is 0 equals 0. So we got 2x. I'm sorry about my handwriting here. I'll just fix it right. Product rule. I circled it up right here, and we put it in right there. So we got 2x plus y plus x times dy dx equals 0. So now what we want to do is we want to get dy dx on its own. Am I right? Or what are we trying to find out here? Let's look at the question. When x equals 2, so we need to find out when x equals 2. So, should we put in the point now? What do you think? No? Yes or no, people? All right, let's not put it in now. Let's oh, at a time. I'm sorry, people. We're gonna have to finish it another time. Thank you. On the other video.